Hello, this is Dr. Mears. Today we are going to be applying our knowledge of geometric sequences and going through this situation. So here we have investing your money. You decide to take $12 and invest it in a mutual fund. The value of your money for each year is shown in the table below. So here we have year 0, 1, 2, 3, 4, 5, 6, 7, 8, and value of an investment. So at year 0, this is just as you're depositing it into the bank, so no time has gone by, it's worth $12. After that first year, year 1, it's now worth 36. Year 2, 108. Year 3, 324. Now, since we looked at the table, let's go through and answer question 1. Question 1 is explain why this is a geometric sequence in one or two sentences. So if we look, if we remember, geometric sequence is multiplying by a common ratio. So either multiplying by 3 or multiplying by 1/3. So let's see, what number do I have to multiply to get from 12 to 36? And now some of you may say, ooh, that's times 3. So 12 times 3 is 36. Now let's say if you didn't know that, what you could do is you can just take 36 and divide it by 12. 36, so I'm just taking this number and dividing it by the number above it. And that's 3. So now we know to get from 12 to 36, we're multiplying by 3. Also, you would ask, how do you know that it was multiplication? Well, if you look at these numbers are increasing. When they increase, that means we're multiplying. If the numbers were getting smaller, then that means that we would be dividing. So since they are getting bigger, we know that that was multiplication. So this helps us to explain why it's a geometric sequence, and the reason why is because we are multiplying by a common ratio. So let's write that in. We are multiplying, by instead of by. Here we go. By a common ratio of 3. And I always like you to put that number in, tell me what the common ratio is. Okay, let's go to number 2. Number 2, write the recursive rule in words for this sequence. So remember, recursive is how do we reoccur to that next one? What are we doing to reoccur from one number to the next? So to get from one term to the next, or to get from one number to the next, let's put one number to the next in our sequence, we must multiply our current term by 3 to get to the next term. And there you have it. To get from one number to the next in our sequence, we must multiply our current term by 3 to get to the next term. Okay, let's move on to number 3. Number 3. After 8 years, your investment will be worth $78,732. That would be amazing, by the way. If that really happened, I would totally invest $12 if I could have that after 8 years. So if anybody knows how to do that, let me know. All right, let's see what the question is. What will your investment be worth that next year? So here we have our years. Here's year 8. So we have to go to that next year, year 9. And so what we have to do is we're going to have to multiply this by, you're right, by 3. So we're getting to that next term. So we're using our recursive rule that we wrote out in words to be able to actually get to that next year. So the math that we're going to be showing to justify why this works is 78732 times 3, and that's going to give you $236,196, which is awesome. So let's write it out in a complete sentence. Our investment will be worth $236,196,000. There you go. Perfect. And so that's the number. If I had you, I might have you fill tables in. So that would be the number that you would put here. Okay? All right, let's go to the next page. here we need to write the explicit rule for this sequence. So first let's write down the rule for geometric sequences, and that's a sub n equals a sub 1 times r raised to the n minus 1. So this is an exponent spot right here. And so for our rule, it's going to be a sub n equals. We are going to have to find this first number at the table. So we need to find a sub 1. So remember, this little 1 here means that first term, but this really means that first year. So let's go back to the table to find our a sub 1. So we go back to our table and we have to look. Our a sub 1 is going to be year 1. A lot of young mathematicians make the mistake of saying, oh, hey, you know, it's the first number that I see, and it's not. So you have to really be careful with this. With geometric sequences, this is what gets you sometimes. So a sub 1 really means look at year 1, or look at where the x value is going to equal 1, and the y value number, this is the number that we're going to use. So our a sub 1 here equals 36. So you had to go to year 1. So let's go back over here and write a 36 times. R is our common ratio that we multiplied by. And so as you can see, our common ratio was 3. So we do times 3 raised to the n minus 1. And so this right here is our answer. And that was supposed to be a little arrow. That is our answer. Okay, so that is the explicit rule right there. Let's now find the value of our investment, after 20 years. After 8 years, it was $78,732. I wonder if we waited 20. You may use your explicit rule, and I'm actually going to use my explicit rule. So now we want to find 20 years. So my n is 20. Please notice how I'm annotating these numbers. So I have my a sub, now it's 20. Equal, so I'm looking for the 20th year. So if I was going to go on my table all the way down to 20 to see how much it's worth, that's what I'm doing. But I don't want to go and do it on my table. I want to use my rule. So it's going to be a sub 20 equals 36 times 3 raised to the 20 minus 1. And I am going to be using the order of operations, meaning I'm going to do parentheses first. Remember, PMDAS, parentheses first. So 20 minus 1 is 19. After parentheses, we're going to be doing exponents. So in the calculator, why don't you type the number 3, the little caret button represents the exponent, and then if you put in 19 and press enter, you are going to be getting the answer of 116,226,1467. So that's the answer you got from the calculator. And I put parentheses around it because there's a relatively big answer. We're still multiplying. I didn't really even need to put the dot there because the parentheses next to this number represents multiplication. So now the last thing that we have to do here in our order of operations is multiply 36 by this number. And when you do that, what's going to happen in the calculator is you're actually going to get this number. You're going to get 4.184141281 and you're going to get this, what looks like an E, it is an E, to the 10. And what this is scientific notation. This means that we're not getting $4.18 back. We're getting a whole heck of a lot more money. This is really times 10. So this times 10 here, this E to E10, means we have to move this decimal point 10 places to make this number really big. So that means we're moving it 10 places to the right. So 1 jump, 2 jump, 3 jump, 4 jump, 5 jump, 6 jump, 7 jump, 8 jump, 9 jump. I'm going to do one more, and I'm going to put a 0. So if you have to go that extra, you fill it in with zeros. So now my answer is 41841412810. Decimal, and then there's no change, so you can just put 0, 0. So this is how much money that I'm getting back. How much is that? Well, let's throw our, wow, that's a lot of money, our commas in. So $41,841,412,810. Oh my gosh. So after 20 years, my investment's going to be worth this much. So please be careful when the calculator gives you this because it's in scientific notation. So just writing this out, my investment after 20 years will be worth oops 810.00. There we go. Wow, that would be amazing. I would do that for $12 in 20 years. Okay, this has been Geometric Sequences Investing Your Money video. Hope it helped. Have a good day.